Hello again, everyone, and today we're going to start looking at our first pieces to programming with VEX Code Pro V5. Now, we're going to start by setting up a few of the motors and sensors and going through the interface so you'll understand what you need to do whenever you need to set up your own brain. But let's start with our file, which is we'll have to create a new one, and we'll go to create a new file, and we need to give it a name. Now, it's always important to give your projects a meaningful name whenever you need to find them in the future. You want to know what exactly they'll be called, so you may call them Activity 1.2.1 or Activity Programming Autonomous Car, whatever it might be. I'm going to call mine Practice right now because all I'll be setting up is a test situation. And I'm going to hit Create. Now once I hit Create, I'm going to see that I have a header here that gives me the name of our main program, which we'll leave as main, your name, the date this was created, and then a basic description. And the only thing you really need to change is your name to make sure it is correct. Below that, we do see include vex.h. Now, this is a library that it's including, and we can see all of our included pieces over here. So if I click on vex.h, I'll see all the pieces that it is including for our program. Now, most of this comes pretty standard with C++ as far as the math and string libraries, but it's also including these, which are our VEX code libraries. And then we're going to take a moment and look at robot config in a second. So all of this you pretty well will leave alone. I just want you to know it's there because if you ever want to do anything exotic, you may have to add in a new library. Now coming back over here, we're going to click on main. Again, this is where we'll do all of our programming. And then below that, you see robot config. And right now we just see brain, and it's establishing that this is the brain. That's part of that vex.h library. Now let's go back to main, and let's add in a few of our basic components. Now if I want to add in a motor, there's two ways I can do that. I could hard code it in robot config, just like the brain is, or I could use the handy wizard that's going to come with VEX Code Pro. I'm going to come up to what looks like a port. Now what it's going to do is allow me to tell it what ports I've plugged things into. Now if I click Add Device, I see several options here as what I could choose to add to my brain. Now I'm just going to do a motor right now. And if I click Motor, I can select what port that motor is plugged into. And I'm going to just say port 1 for now. There are a few options on the screen we want to make sure we pay attention to. The first is the name. And I can't emphasize this enough as you're programming, but you need to use a meaningful name. Motor 1 just tells me a motor, and it might be the first motor I've set up. It doesn't necessarily mean it's the motor in port 1. So we want to give this a name that means something. I'm going to leave it as motor 1 right now, but in the future, when we're setting up a robot, we want to make sure it correlates directly to which motor we're talking about. It'll simplify our coding tremendously. Below that, we have the gear cartridge. Now you have gear ratios of 36:1, 18:1, and 6:1. All the motors we will be using will be 18:1. This is our standard setup. It's supposed to be a balance of both torque and speed. As you can see, it is 200 RPM versus the 100 in the 36:1 ratio, or the 600 in the 6:1. So this is that middle value. Below that, we have the option to have a normal direction motor or a reverse on the direction. We will primarily leave this as normal. It's better to change the direction in the code than in the preset. If you change it here, it can cause confusion later. But if I do click this, you'll notice that the diagram up here will change as far as what direction is going to be considered positive and what will be considered negative. Here we have a positive is considered going counterclockwise, and negative is going clockwise. This has to do with the system of polar coordinates that most programming systems will use as an underlying structure, which are going from quadrant 1 to 2 to 3 to 4. But you really won't have to worry about polar coordinate systems for this application. Mostly it's just going to show you that counterclockwise is positive and negative is going to be clockwise. Now once I finish this, I'm going to go ahead and click Done. And we'll see our screen changes a bit. And I don't see anything here other than a comment that states motor 1 is a motor and it's in port 1. Now, this is a comment, and an important thing to remember about all comments in code is they do not affect the code. They're there for us to better understand the code. So if I want to see where this is actually coded, I'm going to go back to robot config, And I want to see that we have a motor, which is telling me the type of object. The name that I've given it is motor 1. It's in port 1. It has a gear ratio of 18:1, and it's currently set to false, which means we are not reversing that direction. So all of our hard-coded, which means directly typed in settings for our objects, are going to be under the config setting or the config file here. Now going back to main, I want to see if I can add in a sensor. So I'm going to go to add device, and our sensors are going to be under 3-wire. So if I click 3-wire, I see I should have all of my legacy sensors listed. We do have the option to have a motor controller for a 393. We have some accelerometers and some gyros. We really will not use these settings. You do have your options for servos, but let's start with something simple, and let's go to the bumper. Now I'm going to say this is in port A, and notice it's going to change the name to bumper A. Again, you want to give this a meaningful name. So bumper A could be useful. It tells us it is in port A, but if we have more than one bumper, we may need to adjust that. There's no other settings, so I'm going to click Done. Again, this populates to my comments, so I can see bumper A, it is a bumper, and it is in port A. Now, if I were to compile this, which I can do by coming up here and clicking on the Compile or Build button, it builds successfully. But just because a program successfully builds does not mean it does anything or is necessarily working correctly. In fact, our program technically does nothing. We've initialized our bumper and we've initialized our motor, but we haven't typed anything under int main. Int main is the main task, and this is where we'll complete all of our programming actions. Now, occasionally we may do things outside of int main, but for now, we want to make sure we do put all of our code here, otherwise our robot will not be able to function. So let's type in some code. I'm going to hit enter, and I want our robot's motor to turn on. Now, maybe I'm not sure exactly how to type in that code. I'm going to come up to the help section. I see the question mark, and I'm going to go to command reference. Well, I want my motor to move, so it makes sense I should probably look under motion. So I'll click the plus symbol, and I'm going to look around to see what meets my need. And if I come down here, I'll see motor spin. Now motor spin should turn on my motor and allow it to spin until I tell it to stop. So I'm going to type in the code there. I'm going to type in motor.spin, and I'm going to say forward. And I see I've got some red highlighting, and I've got some squiggly lines like I've spelled something wrong. Well, it tells me there's an error, undeclared identifier, motor, did I mean motor 1? Well, if I click this little light bulb here, it's going to say change motor to motor 1. Well, the reason is I'm not just talking about any motor, I have to tell it which motor, and in this case it should be motor 1. So if I click that, it'll correct it for me. How about forward? What's going wrong here? I still that light bulb again, and it's telling me, I misspelled it. I've called it forward instead of forward. I'll click that and it's going to correct it for me. Well, I want to make sure my motor spins. I'm going to go back up to build, and it's successfully built. Well, my code isn't perfect yet, because if I plug this into my robot, I'm going to notice my motor just spins and never stops. That's not going to be a very useful command, so I need to stop it. So I'm going to come back over here, and I'm going to look for something that will fit my need. And I see right here I have motor.stop, and it's going to stop my motor. So I'm going to come back over here. I want to type in motor, and now that it knows I'm talking about motor 1, it's going to remind me about which motor I need to do. And then I'm going to type in stop, type in my opening and closing parenthesis, and a semicolon. And now if I click build again, it's going to completely build it, and I have no errors, which is what I want to see. Now, what this will do is it will start my motor and then immediately stop my motor. Now, this is again not going to do much, because what will likely happen is my motor will start and then stop so quickly I'll never see it move. So I need another command. So I'm going to add in a command here, and I'm going to tell it to wait. And I want to say wait 1000 and colon. Now it's giving me a squiggly line here that maybe something's not right. So I'm going to go to command help. I can do that by right clicking. And it says it waits for a specific amount of time. So I've told it a time, but I've not told it units. So let's do time comma, milliseconds. Well, it says something's wrong with my unit. Let's go to command help. And it said it couldn't find anything. So let's try just seconds. And it's like this. And instead of 1,000 seconds, let's just wait 1 second. So it'll move forward for a second, stop, or after that time is expired, and we'll build to make sure everything gives me no errors. I have no errors, my build is complete. I have now written a program that will start my motor, leave the motor running for 1 second, and then stop.